Hi, my name is Sidan A, a PhD student at Rutgers University. This poster summarizes an ongoing project with Professor Tom Banks. In 1998, Karlov and Solodukhin independently conjectured the equality between fluctuations in the modular Hamiltonian of black holes and its expectation value. Banks and Zurich's 2021 work generalized this observation to any causal diamonds, including cosmological causal diamonds. Through this generalization, the precise normalization of primordial scalar and the tensor power spectra is calculated in this paper. We inspect a quantum inflationary model of the very early universe, consisting of localized excitations in terms of two-dimensional matrix-valued fermionic fields on the expanding horizon. We argue that when the holographic degrees of freedom that couple these excitations are frozen, subsets of the fields evolve independently as localized excitations without equilibrating with the background. Such a quantum system has a hydrodynamic description as a probability distribution of black holes. So we consider an initial condition of a distribution of massive black holes with a central mass value, mass fluctuations given by the Karlov-Solodukhin relation, and angular momentum fluctuations given by the Kerr black hole entropy formula. More precisely, the power spectra predicted by the holographic inflationary model during the slow-roll era are given in section 2 of the poster. We start with a single-field slow-roll inflation model of massless scalar fields in the FRW matrix. In comoving gauge, matrix perturbations can be separated into scalar and tensor parts. To find the solution to the equation of motion for each part, we argue that apart from the slow roll factor coming from classical cosmological perturbation theory in comoving gauge, the probability distribution of fluctuations is de Sitter invariant. This fixes the solution, and from there we compute the power spectra, which are shown in equation 4 in this poster. Then we determine the slow-roll parameter epsilon in this model by fitting our analytic scalar spectrum to the data of the cosmic microwave background. We find the slow-roll parameter epsilon to be approximately 0.1 in this model. This is consistent with observational constraints where the order of magnitude of epsilon is 0.01. Because in the holographic spacetime model, as one can see in equation 4, the tensor to scalar ratio scales as epsilon to the second power instead of epsilon, which is predicted by quantum field theory. More details about the fitting can be found in section 3 of the poster. We use the analytic tensor spectrum to compute fluctuations in the total angular momentum of these black holes. Then the tensor to scalar ratio is fixed by the Kerr black hole entropy formula. Section 4 of this poster covers the main arguments. We would like to point out that this model is constructed to have no trans-Planckian problem. In addition, Banks and Fischler have shown that if one postulates that a tiny fraction of the black holes carry the lowest charge of a discrete gauge symmetry, dark matter emerges from this model as primordial black hole remnants. Thank you very much for your attention. For more details, please see the poster and the upcoming paper.